friends, and now we are going to discuss about the definite integrations. Till now we have done the indefinite integrations. Now you'll be surprised, oh my god, what is definite integration, what is indefinite integration? So the simple answer is that in the indefinite integrations you'll find your answer always in terms of variables, and however in definite integration you will find your answer in terms of the numerical value that are constants. Now without wasting time in history of integrations and this whole thing, we'll just like to go through to understand that what actually is definite integral. So now a definite integral goes like this. A definite integral is denoted by integral x equal to a to x equal to b fx dx. Okay, now this x equal to a is called the lower limit, and this is called the upper limit. Now if you know that this is fx is a function, and that is obtained by integration of something. So suppose if I say that d by dx of fx, if I say d by dx of capital Fx is small x, means if d by dx of fx is this, then antiderivative of fx, that is integration, will be this fx. So here you can say that if I find the integration of this function, then I'll get capital Fx, and then put the value of limit there, that is x is a to x is b. Now put the value of x as b first, so this becomes fb and this becomes fx. Now this numerical expression is the value of this integration. But if the function is not the anti-derivative, then what you'll do? Then you have to find your answer using the integration as a limit of sum. How? I'm going to focus on that. We are finding out the integration with expressed as a limit of sum. How? The whole idea goes like this. First let me clear this part of screen. So here I write here this I x is a to x as b fx dx. Now what is fx? Fx definitely must be a function. It must be having some graphical representation. Definitely it has. This is your function y equal to fx. Now suppose if it is plotted like this, and then the value of x is a, so this I say this x is, this is a lower limit, and this I can say fx, sorry this is not good place, here I write fx, then this value will be your fa, and I say this is my x, this is my b. So this value here will be fb. Now to find out the definite integration of this fx from the limit a to b, we are trying to find out the area of this curve. Suppose if I say that find the area between the curve, means this whole part between the x-axis, then for sake of understanding it was divided into large number of strips, rectangular strips like this. I cannot draw all, I take few. Like this. This is your x naught, which is a. Now increment every time a by small value h. This is a plus h. This is a plus 2s. Slowly this will become a plus nh. A plus nh. So we have n strips here, and then each strip, the area of each strip, if you add up the area of each strip, then you will find that you find the area of this whole graph. So now what is the area of this first one is h, which is the width, and then the height of this function. If you take this and a very large number, suppose if I say, now here you see that b equals a plus nh, means this upper limit minus lower limit, like the b minus a divided by h is n, means b minus a divided by this width, this is the width h. Okay, so b minus a upon h is n. Suppose if you take this, gives you the number of strips. If I say that if limit n tends to infinity, means if there are infinite number of strips, then h will definitely tends to 0, means the thickness of this strip will be so small, just like 0, and since this is a curve function, though, so that it becomes a rectangular strip, a fine rectangular strip. Now if you just pay attention to this part, a b, I write like this, so a b p c and d e, just anything, any random number I have seen, then you see that just look at the whole area. So the area ABED, this smaller rectangle ABED will be more than area of ABPD, ABPE means this part. This is what our focus is, ABPE. So ABPE, and that is lesser than ABPC, area ABPC. So if you make everything so small, so that using the sandwich theorem, the area of this will be based on this rectangular strip idea. So now we are finding out the area of the first strip, that is FA, plus second strip FA plus H. Then final one is HFA plus, and this is HFA plus n minus 1H. Now the sum of all this thing with the idea that limit h tends to 0, limit h tends to 0. Why we are setting the h tends to 0? Because we want the thickness to be as small as possible and the number of strings as big as possible, so that this whole thing, like the ABED, ABPE and ABPC all coincides to become 1. So this is limiting value. Now you take h common and then you write like this, limit h tends to 0, FA plus F A plus H plus dot 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 plus F A plus n minus 1 H. In the whole form, this is a discrete values. So in the whole form of summation, if you want to write this is the summation form, then this can be written as H summation r equal to 0 to r equal to n, and this you write as F XR. Now what is XR? Because if you have taken the strips like this, then the XR, the rth strip will be XR is A plus RH. So this XR is A plus RH and the X0 is A plus 0H, Xn minus 1 is A plus n minus 1H, X plus NHH is A plus NH, like that. So this is what, and this is also written as limit n tends to infinity, this whole thing written as Sn, and this gives you A to B fx dx. So this is the basic theoretical definition of the whole idea. Now we have to solve questions. We don't have to go and debate about finding out how the idea of the definite integration has come. Now we have to solve the question. So I better go directly into the exercise and start solving some question. So now I go into the exercise. These are the questions. Now first question is I equals a to b x dx. You can also do this directly, like first find the integration of this, that is x square by 2. Then you put a box here, put a limit, lower limit here, upper limit here. Now find the difference of the value at the upper limit minus difference of value at the lower limit. So first you put b there, this becomes b square over 2 minus a square by 2, that is half b square minus a square. But we have to solve this question based on the integration as a limit of sum. So this is direct answer, this is not the limit of sum. For the limit of sum, what we have to do, see this is lower limit a, then you know that b equals a plus nh, right? Then h is b minus a over n, or n is b minus a over h. Now we have to find fx. What is our function fx? Fx is x. Now our rh term, you remember it was a plus rh. So if I write here f a plus rh, where the r is the lower limit, so this function becomes a plus rh. Okay, now I write the formula, that is Sn, or the whole thing as limit h tends to 0 summation r equal to 0 to n minus 1 and f xr, that is this one. So this is limit h tends to 0, and then what do we have? We have fa plus fa plus h plus dot 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 plus fa plus n minus 1 h. This way also you can do. Both are same forms, only there is just little difference in the writing. Now limit h tends to 0. If I write limit n tends to infinity, at the place of h we write b minus a by n, and there is h also, sorry, there is h also written there. Here is also there is one h. H into fr, this is the width and this is the height. So now if I write n tends to infinity, then I have h. At the place of h I need to write this is b minus a over n, and there fa. Now see, this is your fx, then fa is what? A plus fa plus h, just a plus h, plus f a plus n minus 1, final one will be dot 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 plus a plus n minus h, and there are total n terms. It means now if I just make a grouping of all of them, then here you just pay attention to this. This must be seen to you all. So this is limit n tends to infinity b minus a over n. Then here the a is there, a is here also, definitely there is a plus 2h, and there are n terms, so a is everywhere, so we have a plus dot 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 n times. And then second time you see there you have h. What is h? Because I am taking common, so it is h, and then what you get? 1 plus 2 plus 3 plus dot 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 plus n minus 1. Now sum of a added n times is just an plus h into, this is sum of the n minus 1 natural number. Sum of the n natural number goes like n plus 1 by 2. So this is sum of the n minus 1 natural number. This will become n minus 1 and n by 2. So this is n minus 1, sorry, here by 2. Now, and this whole thing is here. So here you write limit n tends to infinity b minus a over n. Now I'll clear this part of the screen because I need to go there. Now here I'm getting limit n tends to infinity b minus a over n, and this is an plus h n minus 1 n minus 1 over 2. Okay, now you see here what is nh is, if you see this, look at this term, what is nh? B minus a. So this becomes b minus a over n plus, at the place of this nh you can write an plus h. There are n is here also, n is here also, but I want to take one n common. So first let me take common. The n I take common, so this n is gone, and then this h, I leave this n there only. I'll take one common from this. This become 1 over 1 minus n by 2, and at the place of this h which is inside this, I will just write nh as b minus a. So now this is b minus this n, and this n cancel. So this becomes, this is limit n tends to infinity. So limit n tends to infinity b minus a outside. This is a plus, what is nh? nh is b minus a. So b minus a, and then 1 minus 1 by n whole over 2. Now if you put the limit n tends to infinity, so wherever you have 1 by n, that becomes 0. So what do you get? Final your answer will be, let me remove this part, it's not required. Then what do you need? You need b minus a. N is infinity, so n tends to infinity, so 1 by n tends to 0. So this part vanishes. Now you have a plus b minus a by 2. Okay, so now let me simplify this part. B minus a, this is 2a plus b minus a upon 2. This is b minus a, this is a plus b upon 2, and a plus b into a minus b gives you b square minus a square by 2. Now this is your answer, half b square minus a square. So this is the way it is solved. Here we need to use the idea of the limit, and just keep in your head that if n tends to infinity, 1 by n tends to 0, and the one more handy thing is this relation, which is nh is b minus a. So now this is, I think you understood it well. Now I take another example just to explain the very same idea. I think slowly with some examples, definitely you have the control over this whole thing. So now this is question number 2. Question number 2 is very easy. I just go for question number 3. This question number 3 goes I as 2 to 3x square dx. Okay. Now first we'll write the definition, that this one should be limit h tends to 0, limit h tends to 0, h times f a plus f a plus h plus f a plus 2h plus dot 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 plus f a plus n minus 1h. Now a is the lower limit, so a is 2, b is 3, then n is b minus a over h, b minus a over h. So we have 3 minus 2 over h, that is 1 over h. It means nh equal to 1. Okay, now there we will just write limit n tends to infinity and express h as n. So what is h? H is 1 over n, so this is 1 over n. Now fa, so this is my function fx, is x square. So fa means f2, so what you get? 2 square. Now fa plus h becomes 2 plus h whole square, because keep this in your head, a is just 2, so fa is f2, and the 2 plus h, 2 plus n is like this. So then we have a 2 plus 2h whole square plus dot 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 plus 2 plus n minus 1h whole square. Now all these can be expanded using the formula a square a plus b whole square. So this gives you, first again write, limit n tends to infinity 1 over n, and then we have 2 square. This one gives you 2 square plus 2 into 2 into h plus h square. Then second one, 2 square plus 2 into 2h into h in plus 2h square plus final ones 2 square plus 2 into n minus 1h into 2, 2 into 2 into here, 2 into 2 into h, 2 into 2 into 2h, this is wrong, this is 2 into 2 into 2h, and this is 2 into 2 into n minus 1h plus n minus 1 square h square. Now I take a grouping, see 2 square is here, 2 square is here, 2 square is here, 2 square is here. There are n 2 squares. So 2 square plus 2 square, because there are n brackets. So first term, second term, third term, this is nth term. So you have n 2 square. So if you add all of them together, they will become 2 square times n. Just like if 1 is adding 5 times, then it becomes 5 1. Then 2 square is added n times, it becomes just 2 square n or 4n. So now second one. Second one, I am going from this 2ab term. Just find the pattern. 2 to h, 2 to 2h, 2 to n minus 1h. So if I take 2 common, 2 and h also common, then what I get? 1 here, 2 here, plus this is n minus 1, dot 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 dot, plus n minus 1h. This is the middle term. Now go for this one. H square is here, 2h square is here, slowly n minus 1 whole h square is there. So if you take h square common, what you get? 1 square plus 2 square plus dot 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 plus n minus 1 whole square, and there you write limit n tends to infinity 1 over n. Now the tricky part is, this is bracket here, so limit n tends to infinity, this is infinity should be here, yeah. So 1 by n. Now this is 4n, this is 4h, and this is h square. So first what I do, that I take just, okay fine, one more term, 1 by n, I write this as 4n plus this is 4h. Now the sum of the first n minus 1, this should not be there. This is the sum of the first n minus 1 natural number. This is n minus 1 by 2, and plus this is h square. This is the sum of square of the first n minus 1 natural numbers. Now sum of the square of the first n natural numbers goes like n minus 1. This is 1 square plus 2 square plus n square. This gives you n plus 1, 2n plus 1 over 6. This is the formula. Now we have the sum of square of the n minus 1 natural number. So replace n by n minus 1. So n becomes n minus 1. This becomes n. And the 2n minus 2 plus 1 is 2n minus 1 whole by 6. So this is the sum of the first n minus, sum of square of the first n minus 1 natural numbers. So now here you get this term, that is n minus 1, 2n minus 1 whole by 6. Now we have to put the value of limit. So for that I'll retain this last term and then I'll remove all other terms. So this term now becomes limit n tends to infinity. Now see, here I have n and here I have n minus 1h. Here I have h square n minus 1 and this. Then I have to get rid of this h, because every time you see h is this nothing but 1 by n. What is h? 1 by n. So here only if I write this h as 1 by n, so what you get? 1 by n here, and at the place of this h square I write 1 by n, you get 1 by n square. Okay, now this n and this n cancel each other. So see, this n and this n cancel each other. So now what we get? 1 by n outside. Now the first term 4n plus this n and this n cancel. 2 2s are 4. We are getting 2 n minus 1 plus this n is there. You see, n square, and here 1 n is there. So I take 1 n cancel and 1 n will be there. That is n minus 1, 2n minus 1 over 6, and 1 n is there. Okay, now if I take n common from all, so now see, n common, so here I get n upon n. This becomes 4. Okay, and this becomes 2. N becomes 1 and 1 becomes 1 by n plus, here I take 1 n outside and 1 there. Here I take n square common, so this becomes n square. This becomes 1 minus 1 over n square, and this becomes, actually I am taking n common from 1, like the n common from 1. So n 1 n, I write it right, don't get confused here. So now again I am just going. So from these two I take n common from this also and n common from this also. So it means finally I will have 2n square, because one is coming from this term and one is coming from this term. When 1n is coming from this term, this will become 1 minus 1 over n, and this becomes 2 minus 1 by n. Okay, and down there is 6n. So I cancel 1n by this, so 1n cancel, this power is gone, and this 1n I should take it outside, so this is also gone from here, and this n. I think it's clear to you all. Otherwise, if you write on the paper and then you'll find what actually I'm trying to say that. I'm trying to say that here I have taken 1n common, so n is outside, here from here also. But here I have taken 2n square common, 1n is cancelling this n and 1n is getting outside. I think it's clear. So this is limit n tends to infinity. Now when n tends to infinity, this n by n becomes 1, and then wherever you have 1 by n, that all becomes 0. So what you get? You get 4 plus this is 2 into 1. And what is this? This is 1, this is 2. So this is 2 by 6. Okay, then your answer is 4 and 2, 8. Sorry, 4 and 2 is 6. Plus 2 by 6 is 1 by 3. So 6 3s are 18 and 1 19 by 3. This is the answer we are getting. Now if just to check whether we are getting the same thing or not, if I integrate x square, then what I'll get? X cube by 3, right? Then I put the value of limit, that is 2 and 3 here, 2 and 3 here. Then just this becomes 3 cube over 3 minus 2 cube over 3. This is 9 minus 8 by 3. Now 3 nines are 27. 27 minus 8 is 19. So this is also you are getting 19 by 3. 19 by 3, 19 by 3. These are the same answer. Thank you very much. And then in the next video we'll solve 2 more questions just to clear this idea, and then we are done with definite integration as limit of sum.